Hey, good morning, everyone. My name's Nick Wilson. I'm DTN's Director of Product Management for Weather and Climate Intelligence. I've been working in and around the intersection of, business challenges and extreme weather and environmental factors for nearly 20 years. I'm based up in DTN's region of headquarters outside of Minneapolis, Minnesota. So let's jump into what is an ongoing threat in many parts of the United States. Over the course of the next few days, we're going to see another spread of extreme temperature and heat. For this, we're going to take a look at a specific case study with a large, widespread outbreak of extreme temperatures in the southern United States that occurred at the end of June into early July. So a bit of a background, in this June high heat outbreak, it was really the first widespread outbreak of extreme temperatures that was incurred this summer in the United States. Over 100 million people faced excessive heat advisories throughout the United States, with heat index over 115 degrees in many parts of the southern U.S. That's been a common occurrence with high temperatures exceeding 115 degrees in the southwest United States. Most notably, Phoenix has set a lot of climatological records, but in the southeastern United States, with the amount of moisture and humidity that they get from the Gulf of Mexico, as well as the Atlantic Ocean, a little bit more challenging to achieve those types of heat indices. So anytime it gets up into that range, it's certainly dangerous towards life, equipment, and property. So on June 29th, then specifically when the outbreak really started, heat indices were over 100 degrees over most of Alabama and expected to exceed over 110 degrees in parts of that region. On June 30th, things started to increase even further. And ultimately on July 1st, where most of the impact was seen from this event, temperatures and the heat indices had exceeded that 105-degree time frame for quite some time. So specifically for electric utilities, let's talk about what are some of the factors that extended periods of extreme temperature and high humidity can lead to for significant impacts. First off, and I think that this is one of the things that's most recognizable to you as an electric utility consumer, is increased power demand. When temperatures increase, naturally people are running their air conditioners, which are typically powered by electricity. There may be other cooling appliances like swamp coolers, fans, trying to run your refrigerator and freezers, anything to keep cool. So that typically increases electricity demand significantly. The other factor at play is when you think about the electricity grid itself. What most people don't realize is there's a close connection between the temperature of high voltage power lines and their ability to transmit power. The resistance increases when there's high temperatures, which means that they carry less electricity. And ultimately what this leads to as well is dangerous sagging of the lines. And there's limitations in which how much electricity power companies can pass through so that those lines don't endanger vegetation, transportation right-of-ways, and other things that may fall below the power lines. One of the most sensitive pieces of equipment for the electric utility grid, once the high voltage transmission delivers it near its end location, is transformer failure. Transformers are critical grid equipment. They typically sit very close to homes and businesses to convert the higher voltage electricity to lower voltages that are used by those homes and businesses. And transformers are more prone to fail in extreme temperature and high humidity environments than a lot of the other components of the grid that are even more supercritical, since there's a lot of feeders downstream from substations and other switches. Lastly, when what goes hand in hand with extreme temperatures is always fire risk as well. So, in areas where you have overhead power lines, if there are high winds associated with these extreme temperature events or equipment failures, these can lead to contact up the line with trees or other objects, which can spark and initiate a fire. So a lot of different factors at play that utilities are trying to balance. Just a map then of the high temperatures that we're seeing at the tail end of this extreme temperature event on July 1st of 2023. A little bit difficult to see, but these darker shades of orange across the southern United States indicate high temperatures that were in excess of 90 degrees. And when you factor in the low winds and high humidity that were at play with this event, heat indices were well above 100 degrees for, as mentioned, over 100 million people across the United States. DTN works with Alabama Power and provides outage predictions that are powered by historic outage management system data, and then applying historic weather model and artificial intelligence and machine learning to help predict the number of incidents or damage spots, such as failures of equipment, poles or lines down, that could be the resultant factor from extended periods of extreme temperature. So on June 29th, DTN issued a storm impact analytics event for Alabama Power, which provided context around the start and expected end time of these extreme heat conditions, and provided then hourly levels of granularity for the expected number of incidents or damage spots to be incurred, so that Alabama Power could prepare accordingly with mobilizing additional staff, bringing in the appropriate equipment for repairs that would be expected for failures across their grid, and pre-positioning those teams so that they could respond accordingly to restore service quickly. In this case, this event was classified as a medium impact storm event. Thankfully, not as widespread power outages expected as you would get with a tropical event in the southern United States or a significant line of thunderstorms. But this still is well above the typical norms that are seen, especially in the peak heating hours of the afternoon. You can see that this is a glimpse of some of the hour predictions. The gray line is representative of a typical day in June. For Alabama Power's outages, just due to run-of-the-mill equipment failure, traffic accidents, wildlife incidents, and then the blue line is the outage predictions on that day in the afternoon into June 30th, where you can see that there is an elevated number of outages that were forecasted in the peak heating of the afternoon. Ultimately, we're still awaiting fully audited outage management system information, but the estimated actual incident counts were within 3% of the 813 across this time period that were predicted, which provided a high level of confidence in making the appropriate preparations across the electric system in order to evaluate, monitor, and respond to the high heat event. Another component of DTN storm impact analytics is what we call similar events. As an emergency preparedness manager and electric utility, in addition to consulting weather and impact forecasts, another thing that is typically done in the early stages of their evaluation of a potential environmental impact event is looking at analogs or historic storm or high temperature events that had similar characteristics to what is being forecasted, so that they can go back, look at their logs and understand, what would I do different in order to achieve better outcomes in this upcoming high heat event. In this case, we can see some metadata from the forecasted high heat event. Typically, some of the factors that are involved with widespread thunderstorm or tropical driven outages in the south, such as wind gust, precipitation, are more notable factors. So it's interesting to see in this forecasted event, there's actually no precipitation expected. And what we do is we compare the meteorological characteristics of this forecasted event to all of the events that were used from the historic outage management system data to build, train, and optimize the performance of the predictive outage predictions. In this case, we can see that there's a couple of these events that were identified as being most similar, given their duration, lower wind speeds relative to typical storm events, and of course the lower precipitation rates. On June 29th, coincidentally exactly 3 years prior, July 20th in 2020, as well as August 12th in 2020. These each had very low precipitation amounts across the Alabama Power Service Territory. And not unexpectedly, we can see that each of those had high temperatures into the mid 90s, similar to what was expected on June 29th, June 30th, and July 1st into the Alabama Power Service Territory. So, they could take a look at these events and, roughly see how many customers were impacted from loss of power, how long it took to restore up to 90% of those peak customers that were impacted, and what the peak hourly rates were for damage as well as customers out. So this also provided a lot of additional clues to help the Alabama Power team better prepare and respond so that they could achieve their high heat event restoration targets and goals. This is then a timeline of the expected number of customers to lose power over the course of the high heat event. And what you see, and this is pretty typical with high heat events, is the grid infrastructure will usually hold up all right in the first 24 hours. It's when you get longer periods, especially overnight, where the low temperatures, given the high humidity levels, don't drop down below, say, 75 degrees Fahrenheit, you get a lot of strain in the oncoming second and third day. And not unsurprisingly, that's where the storm impact analytics outage predictions were really focused, was into this second day and ultimately into July 1st as well, as far as the peak number of customers expected to be affected. This is just a glimpse of the Alabama Power public-facing outage map. So this was captured early in the event on June 29th, where you can see that Alabama Power serves over 1.5 million electricity customers, as defined by the meters that are serving homes and businesses. And you can see that the outage counts in the morning of the 29th were quite low, but that increased later in the day. So ultimately, this certainly was a success story for the state of Alabama and Alabama Power, serving its customers. Things were well understood in advance of the arrival of the extreme heat. There were analogs identified in order to help provide an additional level of confidence in those preparations, and they were able to restore power to their customers very quickly. A few of the factors that we see utilities that are agilely preparing and responding better than their peers to high heat events. There's a few steps that they're taking to differentiate themselves. First and foremost is the implementation of an outage prediction system. There's been a significant evolution as far as the use of combining together historic outage management system, vegetation data sets, land use information, and other characteristics of the topology of the grid, and combining that with weather forecast content with artificial intelligence and machine learning to understand the expected magnitude of the outages so that the utilities can mobilize staff, bring in outside contractors or foreign resources, and of course, facilitate their supply chains to get the equipment that they need and pre-stage that accordingly in the areas that are expected to be most impacted by the equipment failures caused by high heat, so that they can accelerate and achieve their restoration goals and maintain customer satisfaction. Because I can assure you that from conversations with our utility partners that high heat events are one of the most challenging to deal with their customer base. When the power goes out, people get upset, frustrated, food spoils. They're obviously uncomfortable, pushed to their physical extremes, and there's no easy escape. Second off, some of the other things that utilities can do proactively are what's known as demand response programs. So utilities can offer rebates for the installation of energy efficient appliances, which would reduce the load on the overall electric system. They can provide incentives for businesses to reduce their energy during peak times in those afternoon hours, and even go to other extremes as far as paying customers to reduce their electricity during heat waves. So this is kind of the irony for high heat events is utilities are actually encouraging and implementing systems for their customers to decrease their use and essentially lower their revenues as far as electricity consumption, because that really at the end of the day is the lesser evil relative to the third component of a risk mitigation plan, which is grid resiliency investments, which are significant capital expenditures, and it's challenging to get the rate approvals from public utility commissions in order to implement those enhancements. So that's kind of the last resort, but certainly a necessary component of these three pillars for mitigation of high heat events. So the last component here is grid resiliency investments, where utilities are necessitating the implementation of new infrastructure that can better cope with extreme temperatures by undergrounding otherwise exposed overhead lines, replacing legacy wooden poles with those that have stronger materials for the poles and towers, and the installation of insulation materials that can withstand higher temperatures. So we see that utilities that combine these three approaches are much better equipped to deal with these extreme heat events, no matter when they occur. So with that, here's my contact information. If you have any other additional questions in and around extreme temperature and how utilities can better prepare and respond to the impacts seen to the grid and customers. I appreciate your time and attention today, and hope everybody can stay cool with the extreme temperatures that are expected across a great portion of the U.S. in the next few days. Thank you.
Thank you, Nick. And I hope all of you can join us for the next two in our summer storm series. The next one up is hurricanes, where we will be looking at Hurricane Ian. And then we will be looking at high winds and hope you can join us for both of those. Thank you and have a great rest of your day.